Math 76, Lesson 1. So today our lesson is going to be going over some specific algorithms for adding whole numbers and money, subtracting whole numbers and money, and then I'll be talking to you about fact families, which is kind of like a niche thing that our textbook uses to teach some truths about addition and subtraction. So first, we're just going to begin with adding and subtracting whole numbers. So I've got a couple of example problems set up here, and the specific algorithm that we're going to be going over is vertical addition and vertical subtraction. Now, to do this, we'll start with the addition problem. Sometimes your problems will be laid out horizontally. So right here we have 3,675 plus 426 plus 1,357. The way we're going to use this vertical addition algorithm is we'll just take the numbers one by one and put them vertically on top of each other, keeping in mind of place value. So here I have the thousands place value, hundreds, tens, ones, and then when I take the next number, 426, I'm going to put those numbers in the appropriate place value. So here I've got 426, and this is probably a review for most of you. Actually, it should be a review for all of you, but I'm going to go ahead and go through all the steps so that way everyone is on the same page. And then I'll take the last number, putting all the proper digits in the proper place value of thousands, hundreds, tens, and ones. From here, I go ahead and draw a vertical line, put the plus sign so I know what operation that I'm doing, and then I start adding the ones column. So 6 ones plus 6 ones gives me 12 ones, 12 ones plus 7 ones gives me 19 ones. I can't put the number 19 all in the column, so I take the second digit, the 9, I put that in the ones digit, and then I'll take the 10 ones and I'll trade them for 110. Which is why it moves over into the tens column. And this is the other reason why I'm going ahead and going through the steps, is because some of you may have noticed I just read this addition problem different than the way that you've taught it. Some of you may not have heard the phrase 19 ones and trading 10 ones for 110. And that's the other reason why, so I can teach you the methodology behind these algorithms that you've probably been memorizing in grade school. So here now I have 110, 7 tens, so 7 or 70 plus 10 would give me 80. Now I've got 8 tens, or 80 plus 2 tens, or 20. 80 plus 20 would give me 100, or 10 tens. 10 tens plus 5 tens gives me 15 tens. And again, I can't put a 2-digit number in the tens place, so I take the second digit of 5, and I will put it in the tens place. Then I will carry over my 10 tens, and I will trade those for 100, which is great because now I'm in the hundreds place. So now I've got 100 plus 600 is 700, or 7 100s. 7 100s plus 4 100s gives me 11 100s. 11 100s plus 3 100s gives me 14 100s. Again, I put the 4 down, and I will trade my 10 100s that are left over for 1 1000. So 1 1000 plus 3 1000s gives me 4 1000s. 4 1000s plus 1 1000 gives me 5 1000s, or 5000. So 5,459. That is my proper answer. Wait, did I add the ones column wrong? Wait, 6 and 6, 12, 13, 19. Yeah, no, I did. We're good. Okay, great. And it's always good to double check your answers sometimes. So for like right there, I had a moment where I was a little confused. If you're ever confused, feel free to go back and check your answer. It happens to all of us, even to your math teacher. Now let's go to the subtraction facts. Here I'm just going to go ahead and arrange them vertically again. Thousands place, hundreds place, tens place, ones place. And then I will put my subtraction symbol, and then hundreds, tens, ones place. Now from here, we're going to kind of be using the opposite logic that we used here, where we traded large amounts to create a smaller amount in the next column. We'll be doing the opposite. We'll be trading down. So here in this subtraction column, I have 4 ones minus 8 ones. I cannot take away 8 ones from 4 ones, so I'm going to go over to my tens column, and I'm going to take one of my tens. So out of these 7 tens, I'm taking 1 10 away, which means it's now 6 tens. And I'm going to trade that 1 10 for ones. 1 10 is equal to 10 ones, which would make this 14 now. And I can do 14 minus 8. 14 minus 8 gives me 6. And then here, 6 tens, or 60 minus 60, gives me 0. And then here, I've got 3 100s minus 1 100 gives me 200. And then 5,000 minus nothing is 5,000. So my answer there is 5,206. So that's addition subtraction using traditional algorithms. Now I'm going to go ahead and use some magic, and we're going to do the same thing but with dollar signs. Poof, I magically have new problems on the paper. So let's go to our addition problem. We've got $6.25 plus $8.23 plus $12. Let's zoom in so you guys can see my imperfect handwriting a little bit closer. So then I'm just going to go ahead and using the same algorithm, I'm going to stack all those numbers on top of each other, keeping in mind of the decimal point separating the dollars from the cents. And we'll notice that the $12 amount does not have a decimal point. So we have $6.25, $8.23, and now for the $12, this is kind of a trick. Hopefully you've encountered it by now. We take our $12, we're going to put that in the dollar amount, and then we'll go ahead and add the decimal point and the 0 cents on the end. And this is all money, so I want to make sure everything is labeled correctly. So from here, 5 and 3 adds up to 8. 2 and 2 add up to 4 or 40 cents. And then 6 and 8 adds up to 14 plus 2 is 16. Carry the 1. And I've got $26.48. So the trick here is make sure that on these whole dollar amounts you're putting the decimal points and adding the zeros. Now let's go to the subtraction. They did the same thing but a little bit backwards. We have $6 minus $1.35. So I'm going to take my $6 and I'm going to go ahead and add the decimal point in the 0 cents. And then I will subtract my $1.35. From here, I notice I can't take 5 from 0. I can't take anything from 0, so I have to take all the way here from my $6. So I'm going to trade my $6 for $5, and then the $1 I took away, I'm going to rewrite that in cents. So if I've got $1, how many dimes is that? Well, that's 10 cents. So that will become 10. But then I also want to take away from that to get to the 1. So if I take away one of my dimes, I've now got 9 dimes left. And how many pennies is that? That's 10 pennies. So 10 pennies minus 5 pennies is 5 pennies. 9 dimes minus 3 dimes is 6 dimes. So, and then $5 minus $1 is $4. So now I have $4.65 for my final answer. Okay, so that's everything as far as addition and subtraction is concerned using these vertical algorithms. Last thing is some words. In addition problems, I'm going to use a different color for this because this is important. In addition problems, we call these numbers addends. Addends. So these are all addends. And if I do make spelling errors, please let me know in the comments so that way I can correct my videos before the next school year finds out that I cannot spell as well as the English teacher. So addends, and then the answer to our addition problem is going to be known as the sum. And then for subtraction problems, we don't really worry too much about the subtrahend and the subtractor here, but we do care about the answer to a subtraction problem, which is the difference. And this is important as we prepare you guys for pre-algebra because words become very, very important in our word problems, and you'll see that later on in the year. So 3 words we need to learn: addend, sum, difference. Sum is the answer to an addition problem, difference answer to a subtraction problem, addends are the numbers being added up. Now, last thing we're going to talk about are subtraction facts or addition facts. So your book will do something a little weird, or at least I thought it was weird when I first saw it, is they will give you 3 numbers. They will say, take the numbers 6, 8, and 14, and they want you to make 2 addition facts and 2 subtraction facts. What they mean by facts is they want you to make an addition problem and a subtraction problem that is true using these 3 numbers. So if I look at these 3 numbers, I ask myself, in what way can I make an addition problem that is true? Now, if I look at 14 and 18, and I add those, I end up getting 22, which is not one of my numbers available. If I add 14 and 6, I get 20, which is not another number available. But if I add 6 and 8, I do get 14, which means that's going to be my addition fact. And then the question becomes, how do I make 2 addition facts or 2 addition problems? Well, all I have to do is reverse my addends, like what we talked about up here. So kind of the idea here is if you're going to use addition and subtraction facts, you need to identify which number is going to be your sum for the addition facts. So for the addition facts, I can write down for my answer, 6 plus 8 equals 14. That is one fact. And then for the other fact, I will write 8 plus 6 equals 14. So these are both true. They are addition problems and they are facts, hence the name addition facts. It's kind of a funny phrasing that the book uses. So the key thing when I'm doing my addition ones is I need to find the sum. The sum is going to be 14. Now if I'm doing the subtraction ones, I need to find the differences. And the reason why I say differences is because you will have 2 of them. So for the subtraction, our starting number is always going to be the larger number, or in this case, the largest number, which is 14. So I'll start with 14, and then if I subtract 6, what am I going to have left over? Well, 8. So 8 would be my first difference. Now, if I do the same logic that I did over here, all I have to do now is reverse it and take 14 minus 8, and I now get a different difference of 6. So 2 addition facts, 2 subtraction facts. So this is something that's going to show up regularly on your homework, just to drive home some points about addition and subtraction. And that's all we've got for lesson 1. Quite a bit to go over, but I think it's good information and it's good practice to go back through these algorithms. And then again, if you ever find that on one of these videos I'm doing something that you've already learned, feel free to hit that speed up button on the YouTube video block, or you can go ahead and skip forward in the video till you get to the specific problem you're having on that lesson. Well, if you have any questions, let me know on the school's website, and I will see you in class.